this example, we're asked to graph the solution set to a system of nonlinear inequalities, meaning that we're given more than one inequality. We're asked specifically about the system x squared plus y squared is less than or equal to 16 and y is greater than 2 to the x. If we think about the related equation, this becomes a very straightforward process. Think first about x squared plus y squared equals 16. That is actually a circle centered at 0, 0 with radius 4. So I'm going to plot that circle first. Keep in mind that when we have a less than or equal to, or in fact a greater than or equal to, we will draw with a solid line as opposed to a dotted line. So centered at 0, 0, radius 4, and I get the following circle. Okay. In the second inequality, we have y is greater than 2 to the x. Since we have a greater than, we know we're going to use a dotted line instead of a solid line. So let's think about, again, the related equation, y equals 2 to the x. This is just an exponential equation, base 2, so that means we would go through 0, 1, and 1, comma 2. And remember, we're using a dotted line, so we get something of this nature. Okay, so that picture should be good enough for us. Now, we need to make sure we shade the proper region. Keep in mind that we have a less than or equal to with regards to the x squared plus y squared, less than or equal to 16. This means that we're going to shade inside the circle. Okay? And also we want to shade above, because we have this greater than, this exponential curve. So that leads us to this region right here. We can, of course, test that we have the correct solution set because we can pick a test point. Let's do that, just to verify. Any test point will do. Let's say 0, 2. What I'm going to do is verify that this test point satisfies both of these inequalities. So I'll just plug a 0 wherever I see an x and a 2 wherever I see a y. So in the first inequality, we have 0 squared plus 2 squared. And I want to see if this is less than or equal to 16. Well, clearly, I get 4, and that is less than or equal to 16, so that works. Now I can do this again for the second inequality. Wherever I see a y, I'll put a 2. Wherever I see an x, I'll put a 0. So I now have 2 is greater than, and I'm asking a question here, let's see, 2 to the 0. Well, remember, first of all, that anything to the 0 is just 1, and 1 is indeed less than 2. So that works as well. So in fact, this shaded region, as well as this line here, this part of the circle, this is the solution set to this system of nonlinear inequalities. In this example, we graphed the solution set to a system of nonlinear inequalities.